So hey guys, welcome back to today's another video. So today is 15th of February 2025 and today we are given this question. Leetcode 2698, find the punishment number of an integer. Let's read the question description. The question says, given a positive integer n, return the punishment number of n. What's the punishment number of n? The punishment number of n is defined as the sum of square of all integers I such that I is greater than equal to 1 and less than equal to n. Okay, so basically I ranges in the range of n, 1 to n, and the decimal representation of I into I can be partitioned into contiguous substring such that sum of integer value of this substring equals I. Such a big statement, right? Let's break this statement and understand what the question have to say. Let's go to our board. Okay, so let's understand the problem, right? So we are given an integer n, right? We are given an integer n. We are given an integer n, and for an integer n, we have to find its punishment number, right? Its punishment number n, right? Yeah. So what's in punishment number of n? We have to find for integer n the punishment number of n, right? And what's the punishment number of n? A punishment number of n is sum of all such i's, all such x, let's say, such that x is greater than equal to 1, that's basically, and x is less than equal to n. Okay, this is my first condition, and my second condition say the decimal representation of I into n, right? So let's say for any x, the second condition say for I x into x, sum of its digits, for x into x, we have to break this string into multiple subparts, right? For example, let's say we have a number, say 1 2 3 4, then we can break how many ways, in how many ways I could have broken it. I could have broken as 1 2 3, or maybe 1 2 3 4, or maybe 1 2 3 and 4, or maybe 1 2 and 3 and again 4, right? So out of all these such combination, right, out of all these such contiguous sub arrays we can form of this number, sum of all such parts equals to x, right? That's easy enough. Let's take an example and see what to understand it more clearly, right? So let's take the example given to us, right? So the first example says n equal to 10, right? So the first example says n equal to 10, right? So what will be my x? So my x would range from 1 to 10, right? My x would range from 1 to 10, no problem with that. Okay, so now I say let's take x equal to 1. Then in that case, x square would be also 1. And if we take the digit sum of 1, right? Oh, that's, and its digit sum, right? Just a minute, and their digit sum would also be 1, right? If you notice, because there is only single digit, right? I can also mention digit sum equal to 1. So you can notice the digit sum is equal to my x, right? Just a minute, I will do this actually, right? So you can notice that my digit sum is equal to 1 as well. So this is one of my valid number, right? Then I move on to x equal to 2, right? X equal to 2. Then I say, hey, is this my valid answer? Then I check for x square, right? So what would be my x square? My x square would be 4, right? And what's my digit sum? My digit sum would be 4, because there's only single digit. I can clearly say 4 is not equal to 2, right? Then I move on to x equal to 3, right? In that case, that would be x square would be 9, right? In that case, digit sum would be, if you notice, digit sum would be 9, right? So this is not equal to as well, right? Then we move on to x equal to 4. Again we then let's do this example completely, right? Then we get 16. If we do the digit sum, then it would be equal to 1 plus 6, that is equal to 7, and we can see 7 is not equal to 4, right? Then we move for x equal to 5, right? In that case x square would be 25, right? So digit sum would be, I will write it in short as ds, as 2 plus 5, right? 2 plus 5, that would be equal to 7, right? This is not equal, this is not our answer. Then we move on to x equal to 6, right? Then in that case x square would be 36. So digit sum would be, sum would be 6 and 3, that is 9, right? Then we move to x equal to 7. In that case x square would be 49, right? In that case our digit sum would be 4 plus 9, that is 13, right? So you have got the pretty basic idea what we are going to do. Let's actually complete this example, right? X equal to 8, in that case x square would be 64 and digit sum would be 6 and 4, that is 10, right? Then we move to x equal to 9. In that case x square would be 81 and our digit sum would be 9. See, in this case we got a perfect match. Now comes the interesting part. For x equal to 10, you would notice x square is equal to 100. Now we can divide this string in many contiguous subparts, right? We can divide, till now we were dividing tens digit at once and unit digit at once, because this was the only option to divide this thing. But for 100 we can divide this thing into multiple parts. How I'm saying, why I'm saying multiple parts, let's just understand why, right? I can divide 100 into either 10 or 0, either 1 or 0 and 0, 10 or 0, or 100, right? So these are my possible ways in which I could have divided the whole string, right? And there's one way, right? There's one way, this specific case 10 comma 0, in which if we add 10 plus 0, then we would get 10, right? So in this case we have a set of digit sum, right? We have a set of digit sum, which is first one says 1, the other one says 10, and the other one says 100. And we see that possible digit sum cases, in one of possible digit sum cases 10 is there, which means we have a possible split. We have a possible split in which our operation, in which our condition satisfied, right? So let's see which of the following got satisfied. In this case a digit sum is equal to 10, right? This doesn't follow, this doesn't follow, this doesn't follow, this doesn't follow. I can see a 9 follows this and a 10 case follows this, right? So what would be my answer? My answer would be in n equal to 10 case. So that would be x square, that is x equal to 1, that is 1, plus x equal to 9 square, that is 81, plus x equal to 10 square, that is 100. So total that would be 182, right? So my answer in that case would be 182. You can see as well the output is 182. So we have got a pretty basic idea of what we have to do, what the question says, and what we have to uh, implement, right? So let's do it a little algorithmically and understand how this question is, how we can implement this question algorithmically, right? So let's just keep this part and remove all other things, right? I will just put it aside. Okay, now moving on, let's see how we can do this, right? So for till x equal to 10 we have let's just bring that back, right? Till x equal to 10 we have already seen, till x equal to 9, that the digit sum is we have to divide only 10 digit and 1 digit, or either we get a 2 digits, right? That's an easy question, that's an easy part of the question. But what if there are multiple digits, right? What if there are multiple digits in the problem? Then there can be many cases, right? There can be many cases in which solution can be different, right? Let's take an example. Let's generalize this actually. Say we have a digit whose digits were a, b, c, d, e, and f. Then the possible combinations were, either we could have done a plus b, c, d, e, f, or we could have done, right? Actually just put a space, not plus, right? Then I could have done a, b, c, d, e, f. Then I could have done a, b, c, d, e, f. Then I could have done a, b, c, d, e, f. Then I could have done a, b, c, d, e, and f. Or also I could have done a, b, and then c, DEF, right? You can see I could have divided multiple strings, right? Not let's do this, right? A single, then we have divided B, C, D, E, F, right? And then I could have done maybe A, B, C, D, and E, F, right? Then I could have done A different, and B, C different, and D different, and E, F different, right? So there are a lot of possible ways, unique ways in which I could have divided this whole number. So doing a little, let's count how many ways would have been there, right? So if we go according to the concepts of permutation in combination, uh, i can say I can say just a minute. uh, I can say there are n places where I can split, right? This is one place, this is one place, this is third place, this is fourth place, this is fifth place, right? So basically I could have chosen to split number among these five different spaces, right? In the first example I chose to split across first place, right? In the second case I chose to split across second space, right? Second part between them, right? In the third case I chose to split between between third case. In this case I chose to split between first, third, and fourth case split, right? So basically at each space, right, at each part, at each split where I could have split this right, where I could have split it, right, at each we have an option either to split it and either not to split it. So going according to the permutation combinations, we at each point we have two options, right? We have two options to either split it and to either not split it. So what would be my total number of possible ways to split this? That is 2 into 2 into 2 into 2. So that would be equal to 2 to the power 5, or which is equal to basically 32. So there are a total of 32 possible ways in which I could have split this 6-digit number, right? So so basically how we can approach this, right? So if you see, there's a recursive type, there's a recursion, right? If you see, if you know a little bit of programming, you will notice we can do it using recursion, right? You can see that we have that, like just like how we split this in at the first part, just like how we split that number at the first part, we again have an option, right? We again have an option when we came at that string, that either we can split at this part, then I can split at this part, and I can split at this part, and I can split at this part. Then again, if I choose to split it, let's just go over there. Let's say we choose to split it that at C part, right? Then in this case I again have a choice to split at D part, split at either E part, right? So you can see I have done both at the splitting, right? So there's a basically a recursive, right? We have to do the same approach again. So we got a basic idea that we might need to approach this problem using recursion, right? Now let's see how we can do this using recursion, right? So let's say just a minute. Let's say we pass a number to the function, right? We pass a number, let's take 100, right? Let's take the case of 100, right? So we pass 100 to my recursion, right? And my pointer starting to this location, okay, right? So I say, just a minute, right? We pass this pointer and say, hey, either consider this number into a current set, or either don't consider this into as a current set, right? So basically if we consider, right, let's draw our case. Let's take the another color, like that is consider. Just a minute. And this is not consider, right? I will just write it as well, consider. And this is not consider. Let's actually increase this arrow size, right? So if we consider this one in our number, then we get the number, we get the whole digit split into two parts, and that would be 1 and 00, right? Again, our pointer moves to this location, right? Then a pointer moves to this location. Similarly, if we didn't had consider that number, not consider that number to in a separate part, then I would have moved to the next location as like this, right? Then I have moved my pointer like this, right? Then my pointer would have moved over here, right? Then I would again have said that whether we want to consider this or not, right? Right, again I had a choice to consider them or to not consider them, right? Again I would have a choice for this number, right? If you can notice, right? So if I had just delete me, right? So if I had considered this number into a different set, then I would have got 0 and 0, right? If I didn't consider that number, then I would get 1 0 0, right? Just a minute, like this, right? And for this case, if I consider this into a different set, then I would have get that z1 0, and if I didn't had considered that, I would have get 100, right? And where would my pointer be currently located? And now my pointer locates at this point, now my pointer locates at this point, now my pointer locates at this point, right? Now my pointer locates at this point. Then again this process would have again followed, right? I would have to do this process once again, right? So let me just again copy this part, right? Then I would have again needed to copy, then I would again needed, just a minute, right? Then I would have again done the process once again. Then I would have again, just a minute, right? Then I would have again done I'm just writing over little over here because there is not much space, right? Just let me shrink it. I would have again done it. I would have again done it in for this as well, right? Just let's shrink it a little, right? And I would have again done it for this part as well, right? No problem with that, right? And you can see in the next iteration my this pointer would have moved to the outer location, and in that case, right, in this case, at this level you would understand that my pointer would have moved out of the index, right? Out of the number of digits we have currently available. So at this level I would do sum of digits at this level, as I have processed right, no problem with that. So basically now I have to do the sum product. Now I would see that 1 plus 0 plus 0 is not equal to the original number 10, right? The 1 plus 0 plus 0 0 0 is not equal to that, but the 10 plus 0 is this, right? So we got an answer in this path, right? We got an answer along this path of the recursion, right? Just a minute, we got an answer for this part of the recursion, right? We got an answer for this part of the recursion. Similarly, we can approach for like this for any number. Either we pick that number into our current set, or either we don't pick our number into the current set, right? Apart from that, when we are going along this way, right, I can maintain a variable in which I store the sum of the numbers, I store the sum of the digits, right? How I'm going, because the main problem now comes at this level, that how I'm going to check for the sum of the digits, right? How I'm going to check for the sum of the digits. So I will also maintain a variable, right? Just a minute. So what I will do is I will also maintain a variable. Let's say that variable is sum, right? So at top level my sum would be equal to 0, right? At this point, right? When I come to this point, I can see I've considered 1 in a different side, so my sum would increase by 1, right? At this side my sum still remains 0. Why? Because I haven't choose any number yet, right? Whenever I do a set, right? Whenever I divide a number, I will consider that digit. I consider that number, add that into my sum, right? Now in this case, I again divided the 0. So I would say sum 1 plus 0, that would again remain 0. So I would say my sum still remains 1, right? Now in this case, I can say my sum still remains 1, right? My sum still remains 1. Now in this case, I can see that I have divided some 10 into the set, so my sum becomes 10 at this point, right? And for this part, my sum still is 0, right? Now when it comes to the next set, right, now when it comes to the next set, again 0 would be divided, right? If the pointer is out of the location when 0 is considered, then again at this point sum still remains 1. At this point sum still remains 1. Just a minute, I will do it like this, right? My sum still remains 1. Then here my sum still remains 1. Then at this point my sum still remains 1. Then, right, if you are getting what I'm trying to say, at this location my sum becomes 10 at this part, right? And if you hadn't considered, then still my sum would have remained 10, right? Just write it over here, and in this case my sum would have become 100, right? And if we had not considered this, then I would have get sum equal to 100, right? So now I have to basically check in which path I am getting the sum equal to 10, right? So I'm getting the paths in this subtree, and I can just easily check for the solution. Alright, so this is a basic simple recursion in backtracking question. I hope you have got this. Now let's also discuss about the complexity of this program, right? What's the complexity for this problem? So you can notice that for the height of subtree, right? The height of subtree is equal to the number of digits in the number, right? So for any x, right? So for time complexity, I would say for a number x, right? For a number x, where uh, x is greater than equal to 1 and less than equal to n, right? Number of digits uh, number of digits in x square would be log 10 log base 10 and x square, right? X square. So that would come out to be log 2 into log 10 x. So I can just remove that, right? So this is my number of digits. Let's represent that as d, right? And I have to do this operation for all of these n, right? I have to do this operation for all of this n, right? And for all of this n, and at each digit I have an option either to consider that and either to not consider that. So I would say I have an option to 2 raised to the power number of digits, right? Number of digits, right? So that would come out to be a total complexity of O of n multiplied by 2 raised to the power, what's my 2 raised to the power? 2 into log base 10 and then and x, right? X, right? And if we are taking an upper bound, I can replace this x by n, right? And also if we are doing an upper bound, I can replace it 2 as well, right? So now our final complexity becomes this, right? O of n into 2 raised to the power log 10 of n. Now let's see if this also works for the given constraints. So if you would scroll down, you would see that the constraint given is 1000. So in the worst case when n is equal to 1000, right? When the n is equal to 1000, my time complexity would be big O of 1000 multiplied by 2 raised to the power log 10 n, right? Log 10, what would that be? That would be 2 to the power 3, that is basically 8 into 10 to the power 3. So that's pretty also easily solvable, no such problem in that problem, right? So let's do this program algorithmic. Let's code this solution, right? So I would start my sum variable, right? Int final sum, right? Final sum equal to 0, right? Then I would say for int I equal to 1 to I less than equal to n, right? This is my number, right? This is my number. I would say if is valid, right? I would check, right? If this is a valid number, is valid punishment number, is valid number I, right? Then I would add that number, right? Then I will add that number into my I variable, right? And in the last I would return my final sum, right, as my answer. Now where this is valid number, let's implement this function. Let's declare this function, let's declare this method as private method, and I would say it's a boolean type, right? It's a boolean type is valid number, is valid number int x. We have got an integer x, right? And I would say instead of doing this mathematically, I would convert the number into a string. Why string? Because it makes recursion easy and will help us to perform this easily, right? So I will convert this number into a string. Let's say string str equal to integer dot to string x, right? I've converted that number to the string. Then I would do a check, right? I will use another helper function, right? I will create another function to provide a abstraction, right? I don't have to do all such code at this level, and I would have to do this at the at only this method level, right? Then I would say return, right, check, right? This is my recursion function, and it would check if this is a valid number or not. So I have to, what I have to start in this function, right? What I have to pass in this function? So basically first I have to pass starting index, right? I have to pass a starting index, and what would be my starting index? My starting index would be 0. After that, what do I have to pass? I have to pass the total sum, right? I was maintaining a variable, right? So this is my current sum, right? Subset sums, I can say sum variable, right? After that, what do I have to pass? I have to pass my string, right? I have to pass my string, and along with the string I have to pass the integer x to compare them at the last level, right? No problem with that. I have passed these variables, and let's implement this check function, right? I will also declare this function as private, right? This is also gonna be a boolean type, boolean check. So this would be my current index variable. This would be, just a minute, this would be my current sum. This is my string, right? This is my string number. In I have a int x, right? I have also got a int x for which we are doing this operation, right? No problem with that. So what I would say, okay, so I would say int current number, right? So current number is currently 0. Then I have a option, right? Then for each index starting from current index, right? From current index till number dot length, right? I have an option to either consider that number, consider digit at, so right, let's say what's the digit at current index? So the current digit, right? So the current digit is number dot char at index I minus 0. Alright, no problem with that. I've extracted the current digit, right? After that, I have an option to either consider that digit or not consider that digit. If I consider that digit, then if I don't consider that digit, then again my loop would process, right? But I have to check, right? I have to check if I consider that digit, then whether it is possible to get the target value, right? Get the x as my answer. So I would say, if I would update my current number first, current number equal to current number into 10 plus current digit, right? Then I would say if check for starting from the next index, right? Check from starting from the next index with current sum plus current number, right? I have to update this, that I have created a variable over there, right? Again have to pass the number in x, right? So I have done this, and in that case, if it's a valid, right, if it's a valid case, right, if the current sum equal to the current number, then I have to return true. And how we are going to check if it's a valid case? I would just say if index is equal to numbers dot size, right, numbers dot length, then in that case we know that we have processed all the digits, right? And in that case I would say if actually I can just return current sum equal to x, right? So we know that if the current sum is equal to x, then it will return true, and it will return true, and it will return to address part. Otherwise just return false, right? Apart from that, I can do a little bit of optimization. We know that if current number exceeds the x value, right, if the current number exceeds the x value, then we know that it is not possible to divide further into any set such that the digits gonna sum up to x, right, because already it has exceeded x. Then I can, in that case, I can directly return false, right? Let's run this code and see if it works. Right, I ran this code and it says a wrong answer. Let's see why it says a wrong answer. Okay, so I just debugged the video and the issue was over here. First of all, we have to check for the x square, right? And second of all, in the final sum, I have to add the square of the number, right, not the number I, right? So I've run this code, it says accepted, and now submit this solution, and we got an accepted. I hope you got this video. I hope you got all the concept, and let me know in the comment section if you have any doubt. And that's all for today. Bye bye.